That's a little concerning. It didn't say this presentation is going to be recorded. Oh
well.
It is showing as recorded.
It's showing as recording now.
Okay, that's fine. I guess because I'm in PowerPoint, it doesn't show me anyway. Okay, so for folks who showed up after I'd already said to Paul and a few other people, if you want to follow along with this, I posted the requirements for this in the NLP group. But basically, they are have Docker Desktop installed, make sure you can run it in the terminal. You shouldn't really need anything else at this point. Yeah, if you don't want to follow along, or if you lose track of where we are, don't worry. I've taken screenshots of terminals all the way through, so you can either just pick up from wherever we are, or just leave it and look at the recording later, and just follow along that way. So, yeah. Do you want to say anything before we start, properly, Paul, or shall I just go?
Then we should probably try and finish about 5:02.
I will try.
Have all the things.
I will try. So Paul asked me to do this presentation, and it started off as one slide deck and has become 3. So this is part 1 of 102 and 103, which will go into further and further depth. Yeah, I suppose I should introduce me for people who might not know me, and for the purpose of the recording. My name is Dr. John Vidler. I work at Lancaster University. I also work for the Microgrid Education Foundation. I'm a operating systems and networking researcher currently working in embedded systems. None of that is Docker. So here we go.
You use Docker a lot.
But I use Docker a lot. I do a lot of prototyping with Docker. So it's kind of bread and butter for a lot of CI pipelines and things like that. So let's get started. So a little overview of what we're going to cover at the moment. So this is part 1, as I said. There are parts 2 and 3 where we'll go deeper. But first up, it's why should you care? Why would you care about Docker? And along with that, some example workflows on where this might be useful to supplant said workflows. And then a bit of the sort of internals of Docker. So what is Docker and a simplified anatomy of a Docker container. I'm going to keep this systems light, but it's useful to know a few of these things so you know what's going on under the hood when you might see slightly strange behavior if you're doing something really complicated. So we'll go through those. And then there's a whole play along at home section, which, like I said, will have screenshots in the slides. So if you miss a step, don't worry, it's all there. And we'll finish with building our own images and a little bit of Dockerfile basics with Python. I should say as well, so part 2 here is where we would go on to multi-container things. So this is single containers for this session. So just firing up a container, getting it running, or as the implicit subtitle of this might be, becoming dangerous with Docker. So this is just to get you off the ground and make sure everything works. Okay. Do stop me if there are any questions, although hopefully we'll have question time at the end and we can sort of Q&A bit. So I'll let Paul shout at me for questions in chat. Is that right?
Yep.
Cool.
That's fine. I'm watching that.
Also, I may be a little rusty. This is the first presentation I've given in 4 years. So, why do we care about Docker? You'll see a lot of cats. I have cats in my presentations. They may highlight things. They may be doing stupid things. I challenge you to count them all. But yes, why do we care about Docker? Docker is beginning to be a develop once, run everywhere paradigm. So this is desktops, laptops, servers. I believe there's now a WebAssembly build for running directly on the web browser. There's a whole bunch of different ways of launching your containers without you having to worry about what you're running them on. So this is isolating your applications and your headaches from the system underneath everything. So this is ignoring the libraries and configurations and runtime environments underneath it. It's just so you run your applications and it works. So hopefully fewer support headaches. Although I imagine once you start messing around with Docker containers, I will get more support headaches from you guys asking me things, but that's totally fine. So I've got some examples of workflows here, and I've got this sort of hypothetical mega NLP database that you may want to run. This doesn't exist. I don't know, actually, Paul, is there a thing called a mega NLP?
Well, there is now.
Yeah, we should definitely create a project called Mega NLP now. We need to come up with an acronym. Yeah, this is the kind of traditional workflow you might have had if you're installing it on your own machine, on your own workstation, even on a server, really, where you go to the website, you download the program or the installer, where you find out it needs some library, in this case, CoolLib24, but you have CoolLib26 and you need it for a whole load of other things in your pipeline, and it's a total pain. So fine, you dig out an old laptop and install Linux on it, and then you go around the loop again. and maybe again, and so on and so forth. And this just becomes a complete nightmare. And this is the user end of something referred to in systems as dependency hell, where you have a bunch of dependencies for different things, and they're all subtly different from one another because the libraries have changed, because the systems they're running on have changed, and it just turns into a nightmare very quickly. And there have been a lot of ways to get around dealing with this. Those of you familiar with Ubuntu might be familiar with something called Flatpak, for instance, for packaging applications with their libraries on a Linux system directly. But this is still effectively installing an application. It's not quite the same as this. So you do that, and you might go, oh, well, okay, fine, I'll do this on a virtual machine. You don't have another laptop, we'll set up a virtual machine. We'll get VMware, VirtualBox, any of the other kind of virtual machine stuff running on your machine. And then you need to install Linux in the bit. So we're just going to leave a cat doing this because it will take a while. So while he's installing Linux, let's try it on Docker. You start Docker Desktop, or you start Docker Engine if you're running on a server, or you've installed that one. I should say Docker Engine is just the command line systems only version of Docker, whereas Docker Desktop is the web, the sort of desktop based UI to the same thing. And we just run the Mega NLP image in a new container, and it's working. Because the Mega NLP image contains all of the requirements for Mega NLP. It already has CoolWeb24, it's already configured. Everything's wrapped up nicely, and we can just hit go. So we should probably check back on the BMCat. Yeah. So obviously this is a simplified situation, and it really should be this simple with Docker in most cases. Obviously, complex problems with complex programs do exist. You know, sometimes you've got a very big program you want to run, and it has to be configured to do that. You don't get away from that because that's effectively the user wants of the program. But the core setup stuff, all of the sysadmining, is just taken away. One caveat with all of this is, generally speaking, graphical interfaces, traditional graphical interfaces, so those that you would see as Windows on Mac, or Xwin on Linux, or Wayland these days, are not as readily possible. It is possible to do things like forwarding the environment through and running things through it, but it's a faff, and it's really not what Docker is designed for. So if you're using command line tools or web services or system services, it's ideal. If you want to run a application with a window, then you need to unfortunately stick to something more like Flatpak or native applications. The workaround for this, however, is web interfaces. So web interfaces are totally fine inside Docker. You can run web servers, you can run all sorts of things that use WebSockets and other web technologies to give you that interface anyway. And indeed, you will find that there are some front-end applications out there now that launch Docker containers in the background to do the real work, while they are just a web browser. So, yeah, some caveats to using any of this. I'm just going to pause for a second and say, Paul, I'm relying on you for timing, because my timer on here is wrong. So,
and that one's
wrong as well. So,
no, it's about right. 13 minutes past.
So, yes, fundamentally, software distribution is a pain. And it can be a huge time sink. And that time sink only gets worse the more people you have using these systems. So whether that's students in the class, whether that's, you built an application, you're selling it, whether it's web users, it becomes a pain. And Docker simplifies all of this by removing the host configuration, the hardware and runtime requirements, without requiring some kind of heavyweight virtual machine or a separate machine to run it. This also has some benefits for host resources and dividing up what is available on a host, but that is all going to happen in part 2, so don't worry about that too much now. But just suffice to say, there are reasons you may want to carve up your system in certain ways. So what is Docker? So Docker itself, on their own website, says it's an open platform for developing, shipping, and running applications, which is exceedingly fancy and very marketing language, but doesn't actually tell you what it is. And you have to get quite far down on the page to figure out what their actual definition is. So let's go further down on that web page. This is, if you search Docker, you will find this on the web. From the Docker website again, Docker packages and runs applications in a loosely isolated environment called a container. Okay, so it's loosely isolated and it has containers. still doesn't really tell us what this is. So let's break this down. Loosely isolated. So a loosely isolated environment is somewhat like a VM, but much, much lighter. So the virtual machines carve up this, or try to isolate the entire, like every aspect of the hardware they're on. So they hide even down to like individual register operations sometimes, they hide everything. We don't care. We do not care that the network card that we're running on looks like an RTL 85 blah, blah, blah. We do not care. We care that it can make a connection out. That's it. So Docker says, fine, we'll just pretend it's a network connection and we won't do anything further than that. You get a much smaller overhead for doing that. But it tries to keep the instances isolated throughout. So it's trying to separate it from the host to save polluting the environment on the host. So you can have lots of versions of Python and lots of versions of Mega NLP without them interfering with each other. And it tries to do the absolute minimum to allow that to happen. We also have container here. So if we look at what a container is, a container simply describes all of the state for an image. As the cat may represent, that still doesn't tell us a huge amount of what's going on here. So what's an image? Well, an image is a read-only template for creating a container. It's effectively the initial state of a container. And very often these are based on previous containers. So you wouldn't need to start from, bare virtual metal every time. You say, I'll just start from Ubuntu, or I'll just start from Python 3, or I'll start from wherever you like. And then you just add layers on top of this. Conceptually, you can think of this as a deck of cards. So we have on the bottom layer sort of the closest match we can find in our existing pile of cards for what we want. And then we put on the variations layer upon layer to make up what we actually do. And usually the top layer is the actual application that you've done. Not always. Sometimes you have a configuration layer, but most of the time it is the application at the top. I can see chat going on. Have I missed anything there?
Mo somehow lost audio, but everybody else is okay, I think.
Okay, cool. I'll just carry on then. When we build our own images, and we'll do this later on, we should aim to keep this stack as short as possible. The higher the stack is, the more complicated this becomes. And it also makes it take longer to download, and it makes it bigger, which is getting away from the whole point of having a lightweight image. You want to have just enough to get you running. And no cap, that's entirely the wrong type of image for this. So what does that look like underneath? And this is where it gets a little bit systemsy, but again, I'm going to try and keep this nice and light, but just so you know what the differences actually are when you look at the architectures for these things. So a traditional virtual machine would look roughly like that. Hopefully this isn't too surprising for anybody. You have your applications at the top, followed by their libraries and binaries, followed by a guest operating system that is then running on a hypervisor that presents virtualized hardware right down to the metal layer, which then itself runs on the host operating system, whether that be Linux or Windows or Mac, or CentOS if you're a masochist. And then underneath that is the actual infrastructure or hardware of your system. So this is your Mac M1 or M2 hardware, or your Intel chips, or your Raspberry Pis, again, if you're particularly keen on it, or me. So this is quite deep. You usually have at least 5 layers here between you and actually running code. There's a lot there to deal with. And in the middle, you're pretending to be something that you're not as well. You're pretending to be some fixed amount of hardware in the virtual machine, which is a waste. So for a containerized architecture, we look at this. So here, we can see this is much shorter immediately. We have our applications and their binaries and libraries, but then we immediately drop to the container engine. And the container engine is as thin a layer as possible between you and the host operating system. So it's just doing that translation and separation and nothing else. It doesn't try and pretend there's a particular card connected or a particular disk plugged in. It just says, hey, it's a block device, have blocks, or hey, it's a network device, have network. And this lets us dispense with many of the layers all the way through. It makes it a lot slimmer. This is what we're talking about, shortening the stack throughout. So the goal, as I've mentioned before, is always to try and make these things thinner. So shorter stacks of things, minimum extras on top of stuff, and try and keep it to just what you need. So now we're heading on towards the actual play along at home section. And we're going to build a view of a very simple web-based container. And we're going to do this in Python. Don't worry, you don't need to actually know Python for this, because I've already given you the Python. Let's just completely skip this. You could do this with Node.js or Bash if you were feeling particularly daring. Or what did you ask for, Paul? I think you asked for Perl in the software survey.
Of course I asked for Perl.
Yeah, of course you did. And we'll give you like PHP or something at some point or other. Yeah, we're going to build a container of our own that's about 3 layers deep. It's not actually, there's a couple of things below that that have to do with like bootstrapping a container from literally nothing, but 99% of the time you don't have to know about that. You can think of the Linux layer or the bottom layer here as the first layer. And we'll explore each layer in turn all the way through. So, play along at home, fire at the terminals. Hopefully at this point you have Docker desktop set up. If you haven't, install it quickly. You're going to need it in a sec. And you can make sure it's working by dropping to a terminal and typing Docker PS. So it's Docker, all one word, space PS, and it should give you nothing running. Or Paul, maybe one running, because you said you had something running before. So yeah, that should just prove that it's actually running. And let's start right at the very bottom, and I'm going to pick Alpine Linux because it's super tiny, which makes it great for demos. So let's run ourselves docker run -it Alpine. As I've said, all of the commands are going to be on screen. If you can't hear me or you mishear anything I've said, or if I bumble anything, it should all be there. These flags here are interactive and terminal connect. This means that it's going to connect your terminal's I/O directly to the container, and it'll drop you straight into a root shell. We're now inside Alpine Linux, and you can wander around in there and do anything that you would like to do within a normal Linux system. So you can ls things, you can cat files, you can, cd between directories and all the rest of it. Like I said before, you know that we're running as root here because we haven't even got any users. We don't arguably need any users within this particular image, or at least it doesn't know that we do, so it doesn't give us that. We're just user 1, root 1, nothing else. For those who are interested, this image is about 7 meg, which is why it downloaded really fast. Can I have a bunch of thumbs up or OKs or working just from people before we go any far? Yeah, so I've got 2 in here. Paul, how are we doing on the chat? Can people shout out if they've got it working?
Assuming we're still connected.
And you've got your volume turned up?
Fairly sure I have.
I should say I can't see the chat, unfortunately, in this setup, so I'm relying entirely on
Feel
Paul.
free to unmute yourself, people, and
yeah, just shout at me if you want to say things. Are we all right, folks?
I don't know, we may have lost everybody, but
is everyone gone?
They're still there.
No, we're here. We're here.
Okay.
I'm just not.
No, we're here.
I'm not running it at the moment. I'm going to try it later. So I haven't got it working, but I'm sure it does work.
Okay, cool.
Mo's there.
Mo, have you got it working? It's gone.
We've got Ezra, Mo, Jamaica, Noran, Daisy, Ignatius remotely.
Okay.
Yeah, mine is not working yet. I need global protect to get on the machine I want to use. Just carry on, I'll follow.
Okay, cool. I mean, we're actually going to start. So there'll be a sort of second stage of this where we go through building a container, and you can pick up from there if you're not caught up by the time we get there. So,
can I ask silly questions at any point?
Yes.
Okay. What does digest and a very long number mean?
So that is the hash of the layer that is Alpine. So when Alpine Linux was published to Docker Hub, and we'll talk about Docker Hub in a little bit, it was given a unique hash, and that is it. It's that 256-bit number.
Oh, right.
And we'll see that come up in a few other things later on, where we have multiple layers. You'll see multiple digest hashes as it joins the container together. When Docker builds a running container from a set of images or set of layers, it does them in order, and you literally see it do it. You'll see it download one, put it on the stack, download another one, put it on the stack. So you'll see it build that image all the way through.
Right. So when you do this the first time, you need to be online and connected somewhere
Yes.
to download these.
Yeah, I'm hoping that the people in the session are online. Otherwise,
Yes,
there are
but-
existential
but
problems.
just imagine,
But yes,
I was on a train to Leeds last week,
yeah, then
and
you
I
would
would
have.
need a connection.
Yes,
Yeah.
yes. So you will need if you're getting an image for the first time, you are going to need to be on the net. But once you've got it, it does maintain a cache of these, and that can actually be a problem later down the line because you can have a whole load of them that you don't use.
Right.
I cleared out one of my servers recently, and it cleared off 640 gigabytes of images because it was doing CI builds and not deleting them when it was done. So they just built up. Each one's only like 300 meg or something, but over the course of several months, yeah. So I'll show you guys how to clean these out in a moment. But let's carry on. I'm going to assume people are okay with things. But yeah, so we're inside Alpine Linux, and it's a full Linux install. It has a full libc layer. So let's install the program inside here.
Sorry, John. I just got on my machine. What was the command you wanted us to type the first time?
There we go. I'll just go back. It's Docker run.
Okay, Docker run IT
Yeah,
Alpine. Okay, thank you.
That should grab you the latest version of Alpine and drop you into a root shell. So yes, Alpine uses APK as its package manager. So let's update the package cache. We have to do this first because Docker is so minimal, it doesn't even have a list of packages in the instance to even search to install the packages. So the first thing we have to do is get that list. So APK update, and you'll see it connects to the internet, pulls some things. And we're going to add htop just so we can see what the system is doing. So let's run apk add htop, HTOP. And you'll see that it installs a couple of things, the incurses and htop, and it should say it's done. It'll say, like it says at the bottom there, it did 9 meg and 18 packages. And assuming you've got that far, you should now be able to run htop. So if you just type in HTOP and hit enter, you'll see that. Which, if any of you have messed around with the Linux system very much, will probably be surprised at how little there is in that window. There's not a lot going on there. We have root running as bin sh, so the root shell, and we have htop itself, and no other processes. This is about as minimal as you can get. This is part of the power of Alpine that makes it very fast. It runs very little. But even if you run something like Ubuntu from a container, you'll find that it is minimized because, of course, it doesn't have to do device drivers. There are no devices to drive. They are already driven. It doesn't have to do filtering on things because things are already filtered. So we end up with much, much smaller working sets here. What's notable here is that I did this on an M1, so I have 10 cores, but you note that I only have 4 showing at the top there. That's 0, 1, 2, 3 is the only 4 cores available to it. So this machine, in this Docker configuration, if I ran something multi-threaded, it might.
Keep going.
Okay.
I'll show you the error in a bit.
Yeah, it might use 100% of all 4 cores. And that wouldn't hang my system because it can only use 4. It can only use the resources of 4 cores, and it can only use a certain amount of memory, which I can't remember what I set to on this, but it was quite small. So you can configure this, you can do it different ways, but it gives you some way of slicing up your system. You remember I talked about carving the system up earlier. So this has sliced my 10 cores down to a chunk that's only 4 to be able to do this, which acts as a little bit of protection.
Ignatius is on
Okay.
Windows and presumably have some.
Ignatius on click to the Docker daemon started on Unix socket post.
Are you running Docker desktop, Ignatius?
No, I'm
No,
running on the command line.
Well, if you've got Docker Engine running and you're sure that it is actually running, just check. It looks like you're in Git Bash there or something. So
it doesn't work through Git Bash.
It doesn't work through Git Bash at all. Okay.
I'm actually on PowerShell. Would that be worse?
Not with that prompt, you're not. That's a Bash prompt.
Works perfectly through the command line.
Right,
the old-fashioned one.
Yeah, so just fire up cmd.exe and run it through that way.
It works perfectly with the command line, right?
Yeah.
All right.
It should work through CMD.
Okay.
I should explain, I'm a Linux and Mac guy these days. I'm not as familiar with the setup on Windows, so I'm going to rely on our now resident Windows expert in the corner here.
So Ignatius, you're running this on the free text VM, right?
Yep.
Okay. Sorry, I thought you were on Windows.
Yeah, I'm not on the Windows. That's what I'm saying. But I'm using PowerShell to access it. So I'll try the CMD and see what happens.
Yeah, have a go on CMD. If that doesn't work, then if you want to have a go through all of these afterwards, I can set you up the VM separately, and you can have a go on that one.
All right, thank you.
Because I've got enough compute to be able to do that. That's fine.
Yeah, you're on Ubuntu Linux, Ignatius, aren't you, on free text? So APK is not the right thing.
Sorry?
He's tried to run the connection, and then that is just added the command into the on-pass, but he's not actually opened a Docker container though. He's just tried to.
Yeah.
It's not
Oh,
working.
is he? Right.
Yeah. So
Okay.
if you're not seeing this /# prompt that we've got at the end here, then you're not inside Alpine. If you're ever unsure, remember you can always type either "who am I" all one word, and it will give you your username, or uname UNAME space -A, that's -A, and that will give you your build information for the current running system. So that should give you Alpine Linux, blah, 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 something if you're in there, and who am I should give you root. If it's not those, you're not in the container. You're looking very fun there. Is it Windows is complaining for your name?
No. When I put
Who am I?
the Alpine, but I am in the container.
Ooh, okay.
It's telling me I'm in WSL2.
Well, yes. Okay, so on Windows, you might be running inside a slightly weird environment because Windows is not Linux and WSL is strange.
It's
So
pretending it is.
yeah, it's pretending to be Linux and it's not. But as long as it's working and you're getting the expected output,
It's working for
it's
me.
all totally fine.
So who am I sees me. Anyway, yeah, I know Docker was installed here. Anyway,
Go on because there are a few things here, and we're
go on, please. Sorry.
So if you've got this, you can see it's very minimal. Is the whole point? There's very little here for you to do anything with. So you're missing things like, if you're familiar with Linux systems, you're missing dbus, for instance. So if your application expects dbus, then you would have to actually find an image that runs dbus as part of its build and then run it. This is about as stripped back as you can possibly be. So if we press Control-C and that should drop back out, and then open a new terminal, /cmd window /ssh connection if you're connecting remotely. So get a new shell session with your host, wherever your host may be, and you run docker ps Polo Sierra. That should give you your running containers. So if you're familiar with ps, the command for Linux that tells you running processes, this is the equivalent for Docker. And we'll see that we're running an Alpine container, unsurprisingly. It's running command binsh. It's been up for however long. In this case, I created it 3 seconds before I did this test. And it'd been up for 2 seconds, so presumably it booted for 1. Yeah, unfortunately, my terminal window wasn't quite the right size for this, but you see at the bottom there, for that first command, it also says fervent poincare is its auto-generated name, which is, I don't know, the Docker names are supposed to be easier to type than the hashes. I'm not convinced. I just copy the hash. It's just easier. But we can interrogate a container with that hash or with that name. They are interchangeable, and we'll see that later. Now, if you type exit in the terminal that's running your Alpine container, and it will drop you back to your host, and then go back to our Docker PS one, or you can do it in the same container. If you do Docker PS-A, you will now see running and non-running containers. So simply ending the container's operation does not remove the container. The container is still kicking around. This you could, for example, restart if you wanted to. You could, in fact, package it up and send it to a different server and run it there if you wanted to. A whole bunch of things can be done with a stopped container. But most of the time, you just want them gone if you're doing development. So let's remove those containers. Actually, before we do that, let's have a look at images. We've brought this up as well. So we've already got this Alpine image, and we've cached it locally now. So if we ask Docker what images it has via Docker image ls, that's Lima Sierra, I think it is. I'm forgetting the phonetics.
Pasting all of the things into the Teams chat as well.
Cool. Then you will see you've got Alpine and maybe others if you've been messing around with Docker previously. And you can see the size. Yeah, I was 7.5 meg for a full BusyBox install of Alpine. Pretty good. And this will fill up over time if you get a bunch of different images for things. If you download Ubuntu images, it will start showing up in there. And you can clean these out via Docker system prune. So if you type in Docker system prune space -h, it will give you the set of all the things you can prune by. You can prune by images, prune by containers, prune by all sorts, networks even. But we're going to, at the moment, just get rid of our existing image. So let's do it the manual way, so you know how to in case you get to this stage. Let's grab the hash of our running container, and this is where you'll have to adapt the command if you're copying commands here, Paul. Docker rm, and then either the container ID or the container name, both of them will work. And as long as the container is stopped, it'll get rid of it. Note, this does not get rid of your container image. So the template for making more Alpine images is still there, but the running instance, the state that we had before, is now gone. Prune does this en masse, essentially. It goes through and can get rid of a whole bunch of these. You also see that it took me 10 minutes to get to this point in the slide between the previous one. I should probably do these faster. Anyway. One minor point, actually, if I just go back there. It says at the bottom left there that you can only remove containers that are stopped. So if you had a container that was running in the background, you would have to manually stop it before you could get rid of it here. You'd have to do docker stop the thing, and then it should bring the container down, and then you can remove it. Docker will tell you, I can't do this if you try that. A lot of the time, I find it's useful to have throwaway containers. So that's a lot of faff to mess around previously with making it and then finding it and deleting it and doing all that. There is, however, --rm, which you can tack onto the end of your run command. So you can do docker run --rm and then the usual -it alpine. And that will give you a container that will only live as long as it's running. As soon as you exit, it's gone. It'll delete it straight away. So good for testing things. Bad if you want to do any persistence. Just remember, if you close that with that RM flag, it's gone. Everything's been trashed.
If you forget and
Yeah.
you close it, or if you forget and then you remember just before you close it, is there a way to stop it?
Yes,
being
let's do
removed?
that in a later part.
Okay.
Yeah,
Advanced.
just be careful when you're running these for now.
Okay.
Like if you're at all worried about this, don't use RM. Just as a blanket rule, it's safer not to. But if you want to just quickly test something, RM's a godsend. It saves you a load of time faffing about finding containers, especially if you have a lot of running containers. Like you're running on a server and there's 30 or 40 containers. This saves messing around.
Right.
Do not rely on this for anything important, obviously. Okay, let's go to Python. So let's grab a Python image. We'll do this in Python 3. So using our throwaway container, having said not to use this for anything important, this isn't important, we're fine. Let's run docker run --rm-it python, and now you see we have :3-alpine. Now everything after that colon is referred to as a tag. So this is a variant of the Python image. There's a whole bunch of variants. If you go to the web and search for Docker Hub, and throw Python in the search, you'll see that there's a lot of them going way back for all different versions of Python. When you run this, you'll see it downloads a few different layers. This is referring back, of course, Paul, when you asked me about what that digest was. You can see that it's pulling a bunch of hashes here, and it stacks them all up, and you end up in Python. And it will drop you straight into the REPL. So this is a bona fide Python 3.11 REPL that I got yesterday. And you can do any Python-y things in there that you like. You can print, you can do all sorts. But let's say you wanted Python.
Sorry, it's Alpine, then Python, and you can only go straight into Python.
From this particular configuration, yes.
Right.
So this is effectively the default configuration for Python, which is just to dump you into the Python REPL.
Right.
We'll go over how to change that in a moment.
Okay.
Yeah, as is the world with Python, with fast-moving languages, it's sometimes useful to be able to get a particular version of Python. How many times has everybody wanted something like 2.7 or something? Hello, Python 2.718. Let's fire this up. So if we type in quit bracket into our REPL to quit from the REPL, which will drop us out of the container and thus delete the container because we used rm. And then we redo the command, but this time do --alpine as our tag, we will end up in Python 2.718. Isn't that much easier than using pipex or any of the other horrible tools to wrangle Python into a working state? Just instantly working.
Just a little bit easier.
Just a tad, yeah.
Especially on the Mac.
Best bit with this, yeah, especially on the Mac. Best bit with this is it also hasn't polluted your system with Python 2. So now, if you were to open a new terminal on your Mac Paul and type in Python tab, it'll only give you the Pythons you have installed. It hasn't actually installed any additional binaries into your path or done any nonsense with your libraries. I put a link here as well. This is hub.docker.com, and it's really annoying that it's /_/ and then Python. I don't know why they've got that in their URLs, but if you do that, you'll see all the different Python versions. Can I click that from here? Will let me? Yes, it is. I don't know which you'll be able to see. You're not going to see this. I won't go through this. The point is, if you go on there and scroll down, you'll find that there are simple tags which have a million different variations. So there are things like Python on Alpine, Python on all the different versions of Debian, Python on all the different versions of Ubuntu. So if you're looking for a really, oh, I've actually got here Windows Server Core LTSC 2022. So, you know, you can do the Windows version of Python if you really want to try.
So it's _/ Python.
Yes, it's very silly.
In the chat.
Yeah. Or if you simply go to hub.docker.com and there's a search bar at the top, just click Python in there, you'll get that.
Okay.
But you'll see there's a whole load of these that you can pick and choose from. So if you're looking for like that special magical version of Python that NumPy wants this particular time round, then there you go.
Right, and these are all, since they're on hub.docker, these are all safe.
Mm-hmm. Any of the ones in the Python package, you'll note that on Docker Hub at the top of the package, if you've got the web page open, is a Docker official image. You want to look out for those badges. There are a few of those. There are ones from specific manufacturers and specific developers. And there's also the Docker official images, which are the core system ones. Keep an eye out for those.
Right.
So, shall we build our own image for that then? Wrong thing again, Cat. So, I have uploaded a template for things. I think I pasted it in the chat way back at the start of this meeting. So if you want to get that, if you don't have Git installed, you can hit that download zip that it's on. It shows you in the drop down for the code button on GitHub, and just extract it somewhere that you can get to with your terminal. And all the following commands should be done from the directory that contains the Dockerfile file. So if you can get your terminal to wherever you put it, in your downloads directory, in your home directory, on your desktop, if you're Paul, then
Rude.
I've seen your desktop. So wherever it is, as long as you can CD into it from wherever you are, or however you get your terminals the way you need them to be, make sure you can get the files there. So what's a Dockerfile? A Dockerfile, much like a Makefile, if you're familiar with Makefiles, is a recipe for making a Docker image. It's essentially a series of steps that you work through that does stuff to give you your final configuration for that image. As a reminder, this should be the static parts of a container. These are not your runtime requirements. This is not where you would, for example, copy a corpus into this. You will end up with a gigantic image that will take forever to do anything with. This is the runtime for WMatrix, Viewport, for instance, so whatever you need from that. This is an Apache web service. This is, the things that are always going to be there. This is not your runtime data. So what does this look like? If you open the Docker file, you'll see that. And I'm going to go through all of these, not quite all of them, because there's a couple of duplicates, but we'll go through them top to bottom, because that's the order that Docker files are passed, unsurprisingly. And we'll see what this kicks out in the end. So, starting from the top, each of these are directives in uppercase. The first word is the keyword. And from Python 3 here is telling Docker, go and get Python tagged 3 from Docker Hub and start from that image. Remembering our deck of cards analogy, this is our first card. You'll note that I've not done -alpine here. This is because we're going to do it with Ubuntu, but vive la différence. If you would like to get this a little quicker, now is the moment to type docker space pull space Python:3. And you'll see why I didn't pick Ubuntu for the initial demo. As everyone watches that download, let's go through the rest of this. So, once we've chosen our base image, so we've started from Ubuntu, we have to have a work DIR. You don't have to do these in this order, but it makes sense to do it in this order. Let's tell Docker where we want to start doing things from. I'm going to put this in user source app. I'm also a fan of putting things in opt app. It doesn't really matter as long as it works within the base image that you've worked from. So Ubuntu would be quite happy if you put it in opt something or home something or source something, as long as it's somewhere we can work safely without trashing the system inside there. So just the same as installing on a normal Linux virtual machine, you just be careful where you put stuff. Opt is quite a good one because there's usually nothing there. So you can pretty safely do that. If the directory doesn't exist, the directive will create that directory for you. Next up is copy, which unsurprisingly copies things. The oddity here is this is copying from the host to the image. So the first path for copy is going to be on the host, and the second path is going to be in the image. We're working with Python, so we might need a requirements file. If you look in the requirements file, it's actually blank, but I've done this because it's quite a common pattern. So let's copy our requirements file into /, remembering that dot is our current directory as defined by our work dir as per normal Linux stuff. So we're just putting the requirements text into our work directory here. There are other ways of using copy that include copying between build containers and running containers, which we'll cover in part 3 if we get that far. Yo,
Hello.
He's
He's been online.
Right. So, yeah, there are other things you can use copy for. You can copy from container to container as well. But like I said, we'll leave that till later. We don't need it for this part. Next, let's ask the Docker runtime to run pip inside our image. So this is asking us to install all the dependencies in our requirements text file within the context of our image. So had we needed NumPy or, I don't know, ChatGPT or whatever inside our container, this is where we can actually install this. Similarly, you could, if you were using a bare Ubuntu container, you could do things like apt-get update, apt-install something. There are oddities in that because apt likes to be interactive. It wants you to say yes or no to things, and there are ways around that. We can go over those when we do more complex containers. But the point is it's running a command within the context of your image. This creates a new layer per instance of run. So every time we call run, we're stacking up that deck of cards. So ideally, we want to keep the number of runs quite low. But you can imagine the number of commands you want to run can be quite high. The workaround for that, and this is a gigantic Dockerfile from one of the bits I'm working on, is to chain a bunch of commands together. So you can always use double ampersand, that and at the end of lines here, to, I'm hoping can I get a mouse on here? Yep, these double ands to chain commands together. The backslash at the end here allows me to do a new line and just continue on the command chain. If you're not clear what's going on with this, don't worry, just have multiple runs for now. When you come to sort of productionize something to distribute it, we can talk about how to convert back and forth from these. It's fine. You'll just end up with more layers than you would normally expect. If you are going to do this, I would recommend that you try and keep co-related commands together. So install all your dependencies as one run. Install all of your Python dependencies as one run. And then you have distinct functions for each layer, because Docker is clever enough to only bother to rebuild a layer when it needs to. So yeah, there's all of this. But don't worry if that particular example is a bit opaque. It's not the easiest Docker file to read. We also have this second copy, but I'm just going to, I know this is the exposed one, but we've got this copy app there as well. Remember that I said that copy ops can be for files or folders. That's copying everything in the app folder, where our Dockerfile sits, into the working directory. So that's all of the files within that, which I believe is just one. I think it's simply one Python file. But if that was a big directory of Python things, it would copy the whole darn lot over at that point. Next up, we have expose, which is a bit of a weird one. So expose is kind of an annotation directive. So it's saying that this image, when produced, will listen on the ports defined by expose. So here we're saying this image, if it's run as a container, will be listening on port 8080 in TCP. That TCP you don't have to actually have. You can just do expose 8080, but I put it in there to illustrate you can specify the protocol as well. We're going to be running a server on port 8080, so we're going to need, well, we don't need that actually. We can do it without it, but it makes it clearer what's going on. You'll find a lot of management interfaces will key off this to say, this container runs on port blah, blah. So it's worth putting them in. It's also useful so you can find out what the heck port you mapped something to when you're building your application. you can interrogate your containers to say, hang on, what are you listing on?
So
Yeah.
if you don't do expose, then there's no route in or out.
No, you
By
can
default.
do it. You can do it. This isn't even opening the route yet. This is the thing. This is declaring that there is the potential for a
No,
route.
right, yeah.
That's why this is weird. So you can open other ports without expose, and it will be totally happy with that. It's just that if you're using this on a bigger system, it may not pick up that that's a possible thing to do. And it's good practice to have them in here anyway. We could delete that line entirely and carry on. And then the last line,
5 minutes.
and then the last line here is actually running the thing. So when the container is launched, when we actually do our run, this is what will happen. It will run Python and the simple webapp.py Python script. It'll keep our work directory from before, so we'll be inside user source app when we do this. Oh, and just as another note, you can have multiple work directories. So if you need to be somewhere else for another set of steps, you can just say workdir somewhere else again, and it will quite happily move you and create things for you. The weirdness on command is that this is an array or list style creation. So it's not like run where it was just a command. Here you actually have to separate out your arguments. There are esoteric reasons for doing this, but this is the recommended way for doing it. So if we go to our folder with Dockerfile, with the Dockerfile in it, we should now be able to run docker build -t. -t is the tag or name of the container we want to make. So I've called it web app, but you can call it anything you like, as long as it has valid ASCII characters. And then space dot, and the dot is important because it's telling us to run this in the context of this current folder. This will then build, and you'll see it grab a load of hashes, or maybe fewer actually, if you've already downloaded Ubuntu. And eventually, when it gets to the end, it'll say it's done, and it'll say Docker scan blah 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 for security vulnerabilities as well. If you've now run Docker image ls, you'll see that we have an image called whatever you decided to call it. Again, I've called mine web app. It has an image ID and was created a few seconds ago, and it's 891 meg, which is why I like to use Alpine if I can. That's quite the hefty lump to have around for nothing, essentially.
Right, so I'm just 5 seconds behind you.
Yep.
So I'm in the, I've downloaded the stuff from your Git as a zip.
Yep.
I've uncompressed it. I'm in the Python web demo folder, and I'm running docker build -t web app.
Yeah,
correct.
Web app dot. The dot is important.
Dot.
Yeah, the dot is saying run here.
I
There
will
are
miss that.
reasons why you would want to not have that be dot, but for simplicity, let's have the dot.
As a general note for machine learning stuff, if you're doing anything with PyTorch, it will immediately add about 3 gigabytes to your build size, which takes you from 10 seconds of build to 10 minutes, go
Yeah.
make a cup of tea, come back,
Yeah.
wait. And therefore the order you put it in your Dockerfile is really important.
Yeah, have your big dependencies early if you can, because then your later ones will be only doing small changes on an existent layer.
Okay.
So, once we've got this, again, conscious of time, don't worry, we're coming down to the end. Let's fire up web app. So, if we were to just do docker run web app, it would run. Unfortunately, it also wouldn't open any ports, so we couldn't actually talk to the thing. So in the interest of expediency, let's just skip to the bottom of this slide here where it says docker run -p, that's a lowercase p, and then 8080:8080. The format for this is local port : container port. I've done 8080 for both. You could do 4000:8080 if you so chose. And it should fire up. And I've highlighted this bit in the bottom right with the ports. So if you've now run docker ps in a separate container, you should see that in your ports column, you'll have 0.0.0.0 : the port you chose going to port 8080 on TCP. If you've got that far, you should now be able to open a web browser, whichever one you like, and connect to localhost : whatever port you exposed. And you will get this glorious web page, which is about as simple as I can manage with Python. And then that is your container reporting from inside there. So congratulations, you have hole punched a container. You're now talking through a web interface that's going through the Docker daemon. You've got a running container you built yourself. All the sources are there you can toy around with if you're familiar with Python. But that's it for now. And I think I'm nearly perfectly on flipping time.
Thank you very much.
Pacing, 4 years out of practice. So, final for now. Part 2 will follow on this, so we're going to talk more about accessing host files, because we haven't dealt with how we would get files to and from the container in the runtime. We only talked about it when we were building containers. We'll cover Docker Compose, so this would be for running more than one container at once. This is the beginnings of container orchestration, where we say, for example, we want a MySQL server and PHP MySQL admin and some web interface, simultaneously all plumbed together. So we'll do some of that, and along with uploading your image to Docker Hub if you want to share it far and wide. Otherwise, you could, of course, share this by source, by having it on GitHub, letting people download it and do the Docker build steps on their local machines. If we get as far as part 4, I'll do multi-arch images, but not until then. Part 3 will be more in the sort of cloud layer stuff. I may get Stephen to do a little bit on that if I can hijack you for some screenshots to show deploying things on stuff. If we get to part 3, if people are interested. Otherwise, thank you for your time and attention. We are exactly 5 minutes to. Any questions?
And applause. And it's working. I've got a little access log popping up.
It's almost like I know what I'm doing.
No, I know what you know what you're doing. It's amazing I know what.